got sensors, so we actually turn this fixture on when the motion sensor is picked up, and so we can save energy.
Okay with photos?
Yes. Right now we're running at about 72 degrees. As you can see, the cold air is coming down from the penthouse through this shaft. The entire data center, we do not have ductwork. There's no supply air duct or return air duct. Okay, so ductless design. We basically pressurize this entire, we call this a space, cold air space, pressurize it at about 0.03 inches of water pressure. That air will then go through the servers and get collected in this hot air containment, as you can see here. So if I open this one, and then you can see it's a huge heat just being, and this area is basically the hot air gets collected in the hot air plenum. So we contain the hot air.
Where's the cool air coming from?
Cool air is coming from the penthouse. We can go up there and show you, okay? But it gets processed and they push it down to exhaust. We exhaust, and we also use a hot air to heat up the office space. So whatever the leftover, just dump it out to this. This particular one is called the reactor power panel because we are using a 480 volt, 277 volt system. We have to deal with a short circuit, high short circuit, harmonics, and the power factor. This is a custom-made panel that takes care of all those three items. So we kind of killed the three birds with the one stone. So this is custom-made. We come this way. Okay, so what you see here is our custom-made server. It's actually it's a one rack. We call it, there are 3 columns here. Each column holds 30 servers. And if you look at it carefully on the right hand side, we have an AC power strip as well as a DC power strip. DC power strip is only used for in case we lose utility power, then the DC power gets supplied into the data center. So this power supply is actually running at 277 volt AC. And it has about a 94.5 efficiency. It's very high. And these are, everything is a front access, everything is accessible from front. So the power cables, the network cable, and then once you disconnect these cables, all the tray just comes out without using any tools.
If power is interrupted, how long can you run on your direct current?
So, good question. This blue cabinet is one thing we developed this product as well. This provides up to about 90 seconds. However, we kind of programmed this so only backing up about 45 seconds right now, because the emergency generator will kick in about within 15 seconds or so. Okay. But this one can handle up at 90 seconds.
You're dealing with seconds, not
correct. And under normal operation, this thing is just it's not wasting any power because it's a standby system. So it's just charging the battery, trickle charge the battery. Your heat coming out a little bit here is that you're just charging the battery. That's all.
So what sort of system do you have set up to detect when you're having any sort of dips or issues where the UPS has to kick in?
You mean the AC or DC? So if it is AC, we have a system that monitors the voltage dip, transient. We also, if anything with the dirty power coming in, it basically goes over to generator. And this is our UPS system. We call it DC UPS system. And the cost is extremely low compared to the centralized UPS system. And it comes in on 2 different models. 56 kW and 85 kW. So using 85 kW, we can actually power up 3 triplets rather than 6. So if you look at it here, all this thing needs is just a receptacle, the plug. goes right up to that AC plug, and you're good to go. One plug. And then there are 6 cables coming out, the DC cables, and then feeds each individual column. And those are all 48 volts, so it's safe. You can, I wouldn't lick it, but you know, I would definitely, it's okay to touch it. It will not harm you at all. Our hot aisle is completely sealed, and if you can just come in for a minute.
Gets warm right away.
Yes.
No lights in here?
No light is required, because the reason we didn't put any lighting here is because no one should ever come to this space. Everything is accessible from the front. This is just capturing the heat and goes straight up to the hot air plenum. Okay? So absolutely no need to come in the back side of the servers. And as you can tell, our Freedom server, we call it open computer servers. You notice this, you can hardly even hear the fan noise, which means the fan is not working very hard. The reason behind that is because we pressurize the cold aisle, and then the pressure is basically going through the servers. So the server fan is working very, very low, not hardly even working. I mean, so you can see, just basically, you know, it's hardly run. I mean, so you can, that's why you're not hearing this bunch of noise. Okay, let's go out there before.
Are all these the open compute servers?
Yes, these are all open compute servers.
Pretty much the whole facility?
That's good. So 1.5U servers instead of 1U server. So the reason why we did that is because, so 1.5U, you could deliver more air through that server, so the fan does not have to work so hard and very efficient. And this is if you make it very 1U, you don't have much area to work with. So the fan has to work really hard to get the air into the server. In 1.5U server, you heard that in the hot aisle. The fan's basically hardly even running. So it's very energy efficient. Run all the data cables, everything above floor, like we see over here. We do not have any raised floor here, obviously. Everything, and we just contain the hot aisle, running everything over there.